Welcome. From nuclear physics, we are discussing about the basic properties of a nucleus. Friends, in this lecture, we have to see what is a nuclear stability. In previous lecture, we discussed about the packing fraction. The ratio of mass defect to the atomic mass of a nucleus is known as a packing fraction. Packing fraction may be positive, negative, or zero. For carbon, packing fraction is a zero. Okay. If packing fraction is a negative, it indicates that the atom have stable nuclei. If a packing fraction is a positive, it indicates that the atom have unstable nuclei. Friends, in this lecture we have to see what is nuclear stability from basic properties of a nucleus. After attending this lecture, student will understand about the nuclear stability. Why nucleus is stable? Why nucleus is unstable for particular case? We know that the atom consists of the positive charge protons and chargeless neutron present in a nucleus, while the negative charge revolving around the nucleus in a circular orbit. The positive charge protons and positive charge proton, there is the electrostatic repulsive force, or we can say that there is a Coulomb force, and therefore the nucleus may be fly out due to the same charges. Proton have positive charge and second proton have positive charge, and therefore there is a electrostatic repulsive force or Coulomb force which should cause the nucleus to fly apart, but this is not happen. Why this is not happen? But in general the nucleus is stable because this there is a nuclear force. There is a force of attraction. The force of attraction between proton neutron and neutron. This force is always attractive force. This force is a short range force, okay, which make the nucleus stable. The proton attract each other due to the nuclear force and repel each other due to the Coulomb force. If the nuclear force is greater than the electrostatic repulsive force or Coulomb force, then the nucleus is stable. But if the electrostatic force or Coulomb force is greater than the nuclear force, then the nucleus is a unstable nucleus. The nuclear force is quite larger in magnitude as compared to the Coulomb force. The attractive force also act between the pair of neutrons and between the protons and neutrons. That is, the nuclear force is a large quantity as compared to the Coulomb force. The nuclear force is a attractive force between the proton neutron and neutron. This force is charge independent force. This force is an attractive force. This force, nuclear force, is a short range force and it is a quite larger than the Coulomb force. There are approximately 260 stable nuclei and there are observed 100 unstable nuclei. The combination of an even number of protons and even number of neutrons composing the nucleus is eventually preferred by a nature for stable nuclei. Or we can say that if there is a even number of a proton and even number of a neutron, then nucleus is a stable nucleus. But there is some case, there is a combination of a odd combination. There is a odd number of protons and odd number of protons and odd number of a neutron, which also stable nuclides for the lighter element or the which having the small atomic mass. Okay, and then odd combination is also there for stable nuclei. If there is a even odd combination, that is the number of protons are even and number of neutrons are odd, then the nuclei are unstable. We plot a graph of a neutron number versus the atomic number or number of proton. Okay, for some stable nuclei. The stability line is when the number of a neutron is equal to number of protons. Then this is which represent the stability line. Note that the light nuclei, that is atomic number is less than 20, are more stable if it contain equal number of protons and equal number of neutrons. That is, if number of a proton is equal to number of a neutron for lighter nuclei which having atomic number less than 20 are more stable. We will also note that heavier nuclei which atomic number is greater than 20 and neutron numbers is also greater than 20 are more stable if the number of neutron in the nucleus exceed the number of proton. If the number of neutron is greater than the number of proton, then the elements or the nuclei are more stable, because when the number of proton decreases or less, the Coulomb repulsive force is less than the nuclear force. Okay, and therefore if the neutron in a nucleus exceed a number of a proton, then it have the stable nuclei. This can be understood that the larger number of a Z, that is number of proton, as number of proton increases, the strength of Coulomb's repulsive force increases, because we know that the Coulomb repulsive force is the force, electrostatic force between the proton, and when the number of a proton is increases, the Coulomb repulsive force is increases. Okay, it is greater than the nuclear force. Nuclear force is a force between the proton-neutron and neutron-neutron, which tends break the nucleus apart. As a result, more number of neutrons are needed to keep the nucleus stable. If number of neutron is more, then the nucleus is stable. Why? If the number of a proton is more, then Coulomb repulsive force is increases, and therefore nucleus is unstable. The number of neutron, that is n is equal to a minus z, that is atomic mass minus number of proton or atomic number required for maximum stability of nucleus, which is plotted as a function of a z. Neutron versus the number of proton or atomic number, and the graph is like this: nuclear stability curve. Here there is a dotted line. It indicated along the x-axis there is a atomic number or number of proton. Along y-axis there is a neutron number. When the number of neutron is equal to number of a proton, then n is equal to z, it indicates that this is the stability line. Okay, the stability region is above the stability line. This indicates that the number of a neutron are more than the number of a proton. When the number of neutrons are more than the number of protons, it indicates that the Coulomb repulsive force is smaller than the nuclear force. Okay. But if the number of a proton is more than the number of neutron, then the Coulomb repulsive force is more than the nuclear force, which became the nucleus unstable, and therefore there is we represent the stability region. Okay. All the stable nuclei fall within the shaded portion of the curve. Nuclei above and below the shaded portion are unstable. The nuclei with atomic number greater than 38 and mass number is greater than the 209. Throughout there is more neutrons, but these neutrons do not compensate the repulsive force of a proton. Hence, these nuclei are unstable. Our assumption is, if the number of a neutron is greater than or more than the number of proton, then the nucleus is stable. But for the nuclei which atomic number is greater than 38 and mass number greater than 209, this assumption is not valid, because after the mass number greater than 209, there is a unstable nuclei. These are the heavier nuclei and which are unstable nuclei. These nuclei spontaneously transfer themselves into the lighter ones through the emission of alpha beta particles. Alpha and beta particle emission enable unstable nuclei to reach the stable configuration. Because we can say that the heavier nuclei is a break into the fission fragment. The fission process is carried out. If we consider the uranium is the heavier nuclei, uranium-238. It breaks into the lighter nuclei. Okay, the fission process is carried out. Okay, the uranium is unstable, but from uranium we obtain the fission fragment which are stable. So this process is carried out. So in this lecture we discuss the nuclear stability. We know that the atom consists of positive charge protons and chargeless neutron present in a nucleus. So the proton have positive charge, neutrons are chargeless. Therefore there is a Coulomb repulsive force between the proton, and there is a nuclear force between the proton, neutron. If the Coulomb repulsive force is greater than the nuclear force, then the nucleus is unstable nucleus. But if the nuclear force is greater than the Coulomb repulsive force, then the nucleus is a stable nucleus. For that, if the number of a neutron is more than the number of proton, then the nucleus is stable. But if the number of a proton is more than the number of a neutron, then the Coulomb repulsive force is more than the nuclear force, and therefore the nucleus is unstable. But for lighter nuclei which having mass number greater than 209 and atomic number greater than 38, atomic number is also more, having the number of neutron greater than or more than the number of proton. So our assumption is not valid for the heavier nuclei. Therefore this heavier nuclei break into the lighter nuclei. Heavier nuclei are unstable nuclei. When they are break into the lighter nuclei, then the lighter nuclei are a stable nuclei. And this process is a fission process, and in this process alpha, beta and gamma radiations are emitted. In next lecture we have to see the problems of basic properties of a